All right, the other day, we solved systems of equations using graphing. That's what we did in section 6.1. This is going to be section 6.2. What was good, if anything, about solving systems of equations by graphing?
Just follow the lines and you got your point?
It's very visual. You can look at the graph, you can see where they graph, you see your answer. Or, of course, if they're parallel, you see that they never cross. So that was a very good thing about graphing. I agree. It's very visual.
And if they're parallel, what does that mean, inconsistent?
Inconsistent. Parallel means no solution, means inconsistent. What if one's right on top of the other?
Dependent.
Dependent, correct. What's bad about graphing?
Takes a long time.
It takes quite a while to do, I agree. What else is bad about it?
You need like graph paper and a ruler.
It needs to be really precise.
You need your graphs to be really precise to get the right answer. The really, really bad thing about it is all the problems you did the other day, the answers came out to be real nice answers. What if your answers came out to be ugly fractions or decimals? How quickly do you think you'll get the answer by drawing two lines and find out that the answer should be 13 over 12, comma 17 over 51? Do you think you would see those on a graph? Not very likely. So, in order to fix these problems, we're going to learn different ways to solve systems of equations. In 6.2, we will learn something called substitution. And then next class, we'll do section 6.3, we'll learn another method called elimination. And so we'll talk about what's good about substitution, what's bad about substitution, and why we might want elimination. Okay, so here's how this is going to work. You're going to have two equations. The first thing you're going to do is you're going to pick an equation and get either x all by itself or y all by itself. It doesn't matter which one. So you're going to pick one of the two equations, whichever one you like better, and you're going to do some work to get either x all by itself or to get y all by itself. Which equation you pick doesn't matter, and which letter you pick doesn't matter. Although we'll see sometimes one is easier than the other, so if you want to pick clever. Step number 2. Take the answer from step 1 and substitute it into the other equation. And that's why this is called the substitution method. And you'll see it when we do some examples. You'll see what I mean when I say substitute it into the other equation. It'll make more sense when we do some examples. And finally, step 3, solve for each letter. All right, so here's an example. Y equals 2x, and 3x plus y equals 10. Okay, so step number 1 is to pick one of the equations, and on that equation get either x alone or y alone. Which equation do you like, and which letter do you want to get all by itself? I like the first one. Why do I like the first one? Y is already all by itself. So step 1 really is done for us. Step 1 says pick an equation and get one of the letters all by itself. That's already done. Step 2 says take the answer from step 1 and substitute into the other equation. So what we're going to do, we're going to take this and we're going to plug it into the other equation. So instead of writing the letter y right there in the second equation, I'm not going to write y. What am I going to write? 2x. So this becomes 3x plus 2x equals 10. Now notice what we have. We have an equation that has how many letters in it?
Just one.
Just one. Well,
one
that's repeated.
Yeah.
It's only got one letter, just the letter x. We can solve that equation.
X equals 2.
Yeah, 5x is 10, and divide x is 2. Not quite done yet, though. Why not? I've got to plug it in. I've got to have an x number, and I've got to have a y number. So I take this x equals 2, and I plug it into one of the two equations, it doesn't matter which one. Which one do you like?
2 times 2.
First one?
I like the first one because it's easier. I plug it in. Y is 4. So my answer would be the point 2 comma 4. Questions on that? All right, let's try another one. How about 2x plus y equals -9, and 5x minus 3y equals 5. All right, well, this one's a little bit harder. Why is this one a little bit harder?
You gotta get them along.
I've got to pick an equation, and I've got to get either x all by itself or y all by itself. So you need to decide which equation do you like and which letter do you want to get all by itself.
First one and y.
I like the first equation in y. Why do you like the first equation in y?
So all I have to do is move the x over on the other side of the equation. And then
All you have to do is move the x over. Why don't you want to get y all by itself on the second equation?
fractions, you get nasty fractions all over.
Yeah, because eventually you'd have to divide by that -3, and you would get a whole bunch of nasty fractions. So one of the goals in doing this is do as much as you can to avoid the fractions. So that's why I say, for step 1, it doesn't matter which equation you pick, and it doesn't matter which letter you pick, but you want to pick wisely. And in this case, picking wisely is to get that y all by itself, because it's the easy one. So I take that equation. How do I get the y all by itself? Subtract 2x. So I'm going to have y equals minus 2x minus 9. Then what do I do with that?
Plug it in.
Sub it in where?
For the y,
For the y in which equation?
the bottom one.
The bottom one. That's right. You've got to make sure you use both equations. So far I use the top one. When I take that, I've got to plug it into the bottom
Now
one.
does the coefficient disappear?
Does the coefficient disappear? No.
Okay.
So we're just going to take that and plug that in. And here's what we'll have. We'll have the 5x. And then we'll have minus 3. And that minus 3 has to be multiplied by minus 2x minus 9. Equals 5. So yeah, our first example, there wasn't a coefficient in front of the y, so we didn't have one. This time we do. We have a coefficient of a -3. So when we plug in, we're going to have -3 times the whole thing we plug in. Now what do we have to do? Yeah, we've got to simplify, we've got to clear those parentheses, add our like terms up, and then we go ahead and solve it.
I'm just a little confused. 5x, shouldn't it be 5x minus 3y?
But remember, we're not writing y, we're substituting in minus 2x minus 9. So instead of writing the letter y right there, I wrote negative 2x minus 9.
Oh, so we're subbing it into the y.
Yeah, we're subbing it in for the y. Yep. All right, so we go ahead and we simplify. 5x plus 6x plus 27. Make sure you distribute the -3 through. -3 times -9 is 27. Is 5. Combine your like terms. 5x and 6x makes 11x plus 27 is 5. We subtract 27. Negative 22. Divide by the 11. X is -2. And a real common mistake people make is they stop right there. Not quite done. What's left to do?
Plug it into either one.
Plug it into either one. And truthfully, what I would do is I would plug it in right there. I think that's the easy spot because that one already has the y all by itself. So I would plug it in right there, and I would have y is -2 times -2 minus 9, which is 4 minus 9, -5. So my answer would be -2 comma -5.
And that's the intersection.
That's where, right, if you were to graph this line and graph that line, that's where they would cross. Now, graphing this line would be pretty easy because we can get the y all by itself. Graphing this line would be a pain in the neck. How come? If you get the y all by itself, you're going to have to divide by that -3, which is going to give you fractions. Or even if you try to do my trick, where I just find the intercepts, what would happen if I build my little table here and I plug 0 in for x?
Still be left with
I'm still going to be left with a
5/3, right?
-5/3. I'm still going to have fractions. So to solve this one by graphing would be really quite difficult, because it would be fairly difficult to get two nice points to be able to use to draw your graph. Could you do it? Yeah, it could be done. But I think the substitution method here is much better. Other questions?
Now you can plug it into the, like, can you plug it in right at the beginning, or does it have to be plug it in after it's simplified and the variables alone?
Plug what in right from the beginning?
-2, the x.
This -2?
Yeah.
Once I get this
You
-2,
plug that into where you got the y, like because on the quiz I was plugging it into the original.
the truth is you can plug it in anywhere you want. I can plug it in here for -2. I can plug it in there. But in my opinion, the easiest spot is right here because it already has the y all by itself.
Yeah.
So truth is you can plug it in anywhere. So pick the easy one. And to me, that's the easy one. All right, let's try another one. How about 6x minus 5y equals -8. And x plus 3y is 14. So once again, we look for the easy one. Which letter is the easy one to get all by itself?
X plus 3y.
You want to use the x plus 3y, and which letter are you going to get all by itself, x or y?
Y.
I would do x.
Um,
Why x?
It doesn't have a number in front of it.
It doesn't have a number in front of it. That's really what you want to look for here. You want to look for the letter that doesn't have a number in front of it. That's the easy one. So we're going to take this equation and do what to it? Subtract 3y. So x is minus 3y plus 14. That's the easy one. What do I do with that x equals minus 3y plus 14?
Plug it into the first.
Plug it into the first one. So I'm going to take this. In the first equation, I'm not going to write x right there anymore. Rather, I'm going to write minus 3y plus 14.
no, if I put 14 minus 3y, same thing.
14 minus 3y is the same thing. Yes, that's correct. Okay, so we have 6 times minus 3y plus 14 minus 5y is -8. And then we simplify to solve. 6 times -3 is -18y plus 6 times 14, 84, minus 5y equals -8. Combine my like terms, a -18y and a -5y is -23y. Plus 84 is -8. I subtract 84 on both sides. -23y is -8 minus -84. -92. And then finally I divide by the -23. -92 divided by -23 happens to be 4. One last thing to do. What's the last thing to do? Plug the 4 back in. Where should I plug it in? Yeah, my opinion is I plug it in there and I plug it into the solved one. That's the easy one to do. X would be -12 plus 14, which is 2. So my answer is 2, 4. Questions on that? All right, so what if the answers don't come out nice? What do I mean by that? Well, I'm just going to make one up here. Hopefully the numbers won't come out nice. 2x plus 5y equals 1. and x minus 3y is 2. Once again, you got to look at that, and you got to decide which one's the easy one.
X minus 3y.
The x minus 3y is the easy one, and we're going to do what? We're going to get the x alone because it's the one that doesn't have a number in front of it. So x is 3y plus 2. I plug that in right up there. I'm going to have 2 times 3y plus 2 plus 5y is 1. I distribute, I clean it up. Let's see, 6y plus 4 plus 5y is 1. 6y and 5y makes 11y plus 4 is 1. I subtract the 4. 11y is negative 3. Y is negative 3 over 11. Not a nice answer. That can happen. Does it really change anything?
No.
No, it just makes it slightly harder to deal with, doesn't it? What do I do with that y equals negative 3 over 11? I still plug it back in, and I still plug it in right there to the solved one already. I think that's the easiest spot. So x is 3 times negative 3 over 11 plus 2. That's negative 9 over 11 plus 2. I think of 2 as being 2 over 1. I need a common denominator. That's minus 9 over 11 plus 22 over 11. That looks like it's about 13 over 11. So, answer, 13 over 11, negative 3 over 11. Now, imagine if you were doing that one by graphing. Do you think you would draw the graph, see where those lines cross, and know that the answer is 13 over 11, comma, negative 3 over 11? It certainly wouldn't be my first guess. So this is where the substitution method is really, really strong, and the graphing method is really, really weak. The graphing method is good only when your answers come out to be real nice answers. If your answers come out to be something like this, you'll almost never get it by the graphing method. Questions on that? All right, 2 more examples. How about y equals 2x minus 4 and 6x minus 3y is 1. What would you do with that?
Use the top one.
Yeah, they've already done some of the work for us. Y is already all by itself. So you're going to take this y and do what with it? Plug it into the thing down there. All right. 6x minus 3 times 2x minus 4 equals 1. That gives me 6x minus 6x plus 12 equals 1. What's 6x minus 6x?
0.
It's 0, isn't it? So what do I have?
Prime.
12 equals 1.
I have 12 equals 1. Does 12 equal 1?
No.
Does 12 ever equal 1?
No.
No. So what does that mean? It means it's inconsistent. When does 12 equal 1?
Never.
Never. So when do these lines cross? Never. Which is a fancy way of saying these lines are, the system is inconsistent, the lines are parallel. So, when you solve by substitution, this is how you know when you have no answer. When you get something that's ridiculous, 12 equals 1, and we know 12 doesn't equal 1, that tells us the lines don't cross. So our answer here would be you could write no solution, you could write inconsistent. Okay? That tends to really bother people when that happens, when they get 12 equals 1. That doesn't mean you've done something wrong. It means your answer is inconsistent. The lines don't cross. There is no answer. All right, one more, kind of along the same line. How about y equals 2x minus 4? I'll stick with that. That was good to me. And this time I'm going to go 6x minus 3y equals 12.
Same thing.
No.
Not quite the same thing.
12 equals 12.
I'm going to end up with 12 equals 12. That's right. Let's just check. I take that and I plug it in. I have 6x minus 3 times 2x minus 4 equals 12. 6x minus 6x plus 12 equals 12. Again, the x's add up to 0. And that can happen. Don't let that freak you out. A lot of people want 6x minus 6x to be 1x, but 6x minus 6x isn't 1x. Why not? Because they're exactly the same. If you take something and then take exactly the same amount away, you've got nothing. 12 equals 12. When does 12 equals 12?
Always.
Always. So what does that tell you about the two lines?
Independent.
It's dependent. The two lines are exactly the same. We have an infinite number of answers. So our answer would be dependent. Okay, so watch for those. Those can happen. Don't let it bother you that the x's all add up to 0 and go away. Not that you did something wrong. All right, so on the sheet, I'm going to jump a little bit into section 6.5 here. Section 6.5 is a whole section on word problems. Yay. So I thought it would be a good idea to start a couple of them here, and we'll see what's going on here. So it says, the length of a golden rectangle is equal to about 1.62 times the width. An architect wants to design a room so that the floor is a golden rectangle with a perimeter of 50 feet. What are the dimensions of the floor? Okay, so first off, we're building a rectangle, correct? Rectangle looks like that. What are we trying to find?
The perimeter?
I'm not trying to find the perimeter. The perimeter is 50 feet.
Oh, okay. You're trying to find out how we got 50 feet.
Okay, so what are we trying to find?
The equation?
The dimensions, and explain more about dimensions.
That's about all I know.
Well, what do we usually call the
Oh,
dimensions?
well, length, width, right?
Length.
Base, height.
And width. Okay, so we're trying to find length and width of the rectangle. That's what the dimensions are. The point is, we're trying to find two variables. We're trying to find length and width. That's two variables. If you're trying to find two variables, how many equations do you need? Two. What if I was trying to find three variables? I would need three equations. If I was trying to find 10 variables, 10 equations. Okay, so we're trying to find two variables, length and width. We need to come up with two equations.
L equals 1.62, W should be 1, right?
The length is equal to 1.62 times the width. I agree with you completely. The length is 1.62 times the width. So there's one equation. So how come we need two equations?
You just can't solve it with just that.
You can't just solve it with just that, can you? You can't tell me what the right number is for W or the right number is for L. There's a lot of numbers that would work, right? If I were to plug 1 in for W, I'd get an answer for L. If I were to plug 10 in for W, I'd get a different answer for
It
L.
would be L plus 1.62W equals 50.
Nope. But you got the right idea. The thing we haven't used yet is the perimeter. How do you find perimeter of a rectangle?
Yeah.
Add what?
All the sides.
All the sides. So when I add all the sides, I'm going to have a length here and a length there. So that's going to be two lengths, and I'm going to have two widths. So there's my second equation. The perimeter is 2L plus 2W, and we were told we want the perimeter to be 50. So there's my second equation. How would you solve that system of equations?
Log 1.62W in for L.
This one's already solved for L, so we can go ahead and stick it right into the other equation. 2 times 1.62w plus 2w is 50. I multiply. 2 times 1.62 happens to be 3.24. W plus 2w is 50. So that's 5.24w when I combine those is 50. And I divide what'd you get?
9.54.
How much?
9.54.
9.54. So W should be 9.54. How do I find L now?
You plug in W.
I plug it in. I'm going to take that and I'm going to plug it in back up there. And I guess this should be feet, right? 9.54 feet. So L is 1.62 times 9.54. Calculator says
15.45.
15.45 feet. Questions on that one? All right, so let's try number 2. An official table tennis, also known as ping pong table, is a rectangle whose length is 1 foot less than twice the width. The perimeter of the table is 28 feet. Find the dimensions. Okay, so once again, we're trying to build a rectangle. And we have length and we have width. So once again, we're trying to find two things. I need two equations. Anybody got an equation for me?
L minus 1 equals 2W.
L minus 1 equals 2W.
L equals 1 minus 2W.
L equals 1 minus 2W. All right, so length is L equals 1 foot less than. What does 1 foot less than mean?
Minus 2W.
I don't think so. If I told you you had $1 less than 5, what would you tell me?
And 4.
4. So what did you do with that 1?
Subtract it.
Subtracted it from something.
So L
So if you have 1 less than something, that means you're starting with something and subtracting 1.
So it's 2W minus 1.
So it's 2W minus 1, correct. And how about a second equation?
L plus 2W equals 28.
Perimeter. 2L plus 2W is 28. I'm going to stop there. I'll let you solve. I did the hard part. The hard part of word problems is always getting the equations. Can you solve those pretty easily? I would hope so. This one already has L all by itself, so you should just be able to go ahead and plug in.